Alright, Module 11. Well, if you're hot under the collar after thinking about global warming in Module 10, it's time to kick back, put your toes in the sand, and we're going to ponder some tropical weather as we head into Module 11. Now, technically, the tropics include all locations north of the Tropic of Capricorn and south of the Tropic of Cancer. If you don't remember those locations, head back to Module 1 and study some of those world maps. Tropic of Cancer is in the northern hemisphere, 23 degrees north of the equator. The Tropic of Capricorn is south of the equator, 23 degrees south of the equator in the southern hemisphere. Anyway, any location within this region has at least one day a year in which the noontime sun is directly overhead. It's the region of the Earth which receives the greatest amount of energy from the sun. As you've probably figured out at this point in the course, what we call weather is really just the Earth's reaction to this imbalance of solar heating. To correct this imbalance, air moves poleward away from tropical regions, kicking off what is called the general circulation. You've heard that before. Remember the general circulation models used in climate change forecasting we introduced in Module 10? However, as you'll learn, the transfer of energy from the equator to the poles is not a sprint. It's not just a direct trip from the equator to the poles. Remember, we're on a spinning Earth. So it's more of a relay race with several circulation cells getting into the act of transporting heat energy away from the tropics. And speaking of getting away from the tropics, you learn about the region just to the north of the Tropic of Cancer and just to the south of the Tropic of Capricorn. That's a region called the subtropics. Pay particular attention, starting on page 434, to how the conservation of angular momentum, as well as seasonal variations in peak heating, cause changes to the position and strength of what's called the subtropical jet stream, the STJ, over the course of the year. This annual variability gives rise to monsoon seasons in southern Asia, as well as in America's desert southwest. And we'll also look at the mechanisms behind longer period climate patterns, such as El Nino and La Nina.